Here's pre-calc. This is problem 8-68. It says consider the graphs of y equals cosine x plus pi and y equals negative sine x. Sketch both graphs on separate axes, and what do you notice? So I know sine x, the parent function, it starts at the origin, it goes up and down, and then it ends up 2 pi, the end of the cycle is 2 pi away from where it started. But I know, like we know about h and k, this is a sine graph. It's like the parent function moved left by pi. So for this locator point, I'm going to start my sine graph left by pi. So I'm going to place that first point there. And then usually when I'm doing it, I just, I know that the period of pi, it's going to make, the period of sine, it's going to make a full, it's going to go between 0 and 2 pi. Like the length is going to be, the period is 2 pi. So I know from here to here is a full cycle. It's 2 pi. So I put my ending dot there, my ending point. And then I know it goes through the center line. And it goes up first and down second. So, I mean, just one cycle would be like this. And if I want to keep it going, it would keep going. Okay, and so that's sine of x plus pi. Now negative sine of x, it would be the parent graph, and these points, these 3 points would be the same, but it's going to be flipped over the x-axis, so it's going to go down first. So it still have this locator point, but then it's just, instead of going up first, it goes down first. It still has these 3 points. So, but isn't that exactly what's going on over here? So these two graphs are the same. So we're supposed to answer their question by saying, you know, the graph of y equals sine of x plus pi is exactly the same graph as the sine of negative x. And that might not surprise you too much. Now, next we're asked to look at the graph of cosine x plus pi. So I'm going to do the same procedure with cosine. This is the parent function. I start my first locator point, I have it on the y-axis at 1, but I'm going to move it left because this is x plus h, move it left by pi, so that's this point right here. And I know that if I use 5 points to graph my cosine function, I know that the last point is a distance of 2 pi away from where the first point was. So I know that's, you know, pi and pi, it's 2 pi. Okay, so that gives me cosine of x plus pi, and it keeps going in both directions. So what they're asking me, what does it look like? Well, my guess was that maybe it looks like negative cosine x, and I don't really even have to do any extra work. I can see that it looks like a negative cosine x. This is going to go. Okay, so we're supposed to say negative cosine x. And then the last question is, use the unit circle to explain why adding pi to the angle x reverses the sign of the x and y coordinates. So that might be where you get a little stuck. So the x and y coordinates, let's just use pi over 6. So the x coordinate is √3/2 over here, and the y coordinate is 1/2. This is cosine, √3/2. And this is sine. If I add pi to, anyway, if I add pi That's like a half circle around, right? So that's going to be over here. And look what happens. The cosine is the exact same cosine, but opposite, negative, opposite sign, right? And then sine was positive here, it's negative there. You can look anywhere on the graph, like, okay, look here. If I go all the way to the other side, sorry. Okay, so from here, if I went pi, you know, if I added pi to it, then I end up down here. And notice that we have the same exact coordinates, but the signs like as in positive or negative are reversed. Okay, and they're asking you like, well, why do you think that is? Well, one thing you could say is that, you know how like one quadrant is 90 degrees and then two quadrant, that's 180 degrees, which is pi. So, and you know how they change signs, like they go from positive to negative. Like in this one, everybody's positive, right? Sine and cosine are positive. Over here, cosine's negative and sine is positive. Over here, they're both negative. And over here, cosine's positive, but sine is negative. Well, when you add 2 pi to something, sorry, not 2 pi, when you add pi to something, you're kind of like skipping it ahead by 2 quadrants. And that kind of explains why you're getting you're getting the same coordinates, but just opposite sign. And you can check it's true all the way around, even here. Here. Okay, and that's all they wanted out of that one. I hope that helped.